Hello and welcome everybody to another episode of Inside AMG. Now, a couple weeks ago, you had the chance to ask us all your questions about e-performance, and now I have your questions right here, and I'm going to meet a couple of experts in today's episode that are going to answer those questions. So stay tuned to find out if your question made it into the final video, and I'd say it's about time we go and meet our first expert. So come on, follow me. We divided your questions into different categories, and the first category is going to be batteries. So we are here at the very busy battery workshop to meet up with Dennis, and you might remember him from the OMG episode. We already answered some battery questions in that episode. If you want to watch it again, click the link up top or down at the bottom, and there he is. Dennis, hi.
Hi Felix, good to see you.
Good to see you too. Thank you very much for taking some time out of your busy day to enlighten us once again about this beauty right here.
Yep.
And I'd say we kick things off with the first question by Bugatti Lover 07, very cool username. What is its capacity?
We have just a small capacity because we're more focused on the high power, so we have 6.1 kilowatt hours for this battery.
So not the focus of this battery to be big, but to be powerful.
Yeah, right.
Nice. Arthur Knaub asks, how much does it weigh?
Same answer actually. We focus on the performance, and therefore we have a small battery and just 89 kilograms. So we were focused very much on the development to take out every single gram on each part what we have to take out the weight of the system.
That's really very light for a hybrid battery, I have to say. Very impressive. Sanji108X asks, what is the lifespan of the batteries and how green are they to recycle at the end of their life?
We have different tests with the battery, so also lifetime tests to see what will happen in the future on different test benches, and we see that we know some aging of the cells and no aging of the system itself, but it's everything in the tolerance where we say the customer will get the performance battery over the lifetime of the car, so that will not be a big problem. And coming to the recycling of this battery, you can take down the battery to the single cell. Even we can take the chemistry out of the cells, so you can disassemble actually everything of this battery.
So not just performance in mind, but also sustainability, a very intelligent concept when it comes to not just assembling, but also disassembling everything.
Exactly. We don't have any glues inside. The cells are glued in this system, so we can take it out, everything. Yeah.
Very nice, very nice. Simon Peters asks, what makes this battery pack better than its competitors, especially Tesla and Volkswagen?
It's not so easy to tell why it's better. It's different. It's a lot different. And it makes, on the performance side, it makes it better because we were focused on the peak power, on 150 kilowatt in peak power, but also 70 kilowatt in continuous power. But it's more the focus on the performance and not the capacity of the system.
So not as easily comparable as one might think. One battery does not equal the other.
Exactly, yeah.
Petronas07, cool name, asks, how long is the warranty of the batteries in the AMG EV performance car? Thank you.
Well, the warranty is actually similar to the vehicle warranty what we have. So we have the same service life, especially to the vehicles.
So yeah, if you decide to buy an AMG Performance Hybrid, you always get the complete package.
Yep.
Nice, very cool. Gamefire PDF would like to know, how long will it last during racing till it overheats, and how will the cooling work? Now that's a very interesting one.
It's dependent on your racing style. It's dependent on the track actually. It's depending on what do you do with this battery. You can come over 45 degrees, which we have claimed that we are at the 45 degrees. So it's still dependent on the racetrack, but it doesn't matter because of the cooling itself. So we have a completely direct cooled battery. So this system here is flooded with oil, and that's why we can cool down the battery to the temperature what we need.
Related to that also, the question by Göpi, what is the C rate of the new battery?
We have, in charging, we have 20 C just for the charging and 33 C just for discharging. So when you take the power, need the power, you will get it immediately.
That is really exceptional, and probably also largely due to this very innovative cooling concept.
Yeah, definitely.
Cool, very nice. Vier Augenbeli would like to know, what were the requirements for the cell and why did you choose this particular one?
We have chosen the cylindrical cells just because of the size. If we take a smaller size instead of a pouch or prismatic cell, you have a bigger surface. Bigger surface means you can cool down the battery itself better than with other formats in the cells.
So actually a very interesting detail also. I mean, these round cells, the actual batteries themselves in there, they look just like a regular battery that you would put in a flashlight, but here they are put to a very different use.
Yep,
definitely. Very cool. Lefteris Zadok asks, at what percentage does it resemble the F1 car's battery?
I don't know if I can tell you everything about it, but so far as I can tell you, the concept is quite the same. So we have cylindrical cells, and these cells are completely flooded and direct cooled with an oil. And due to the package and different situations in the car, what we need to have redesign of the system, but it's in the concept, it's quite the same.
Pretty cool. So F1 racing technology for the road, once again, from AMG. Charles N0312 asks, electric shock risk, is it dangerous to work for the technicians on this battery?
Yes, definitely. So we have to be careful. We're focused in the development to make it as safe as possible, and you have to be special trained if you work on these batteries. So everybody who is working on these batteries has different special trainings just to make sure that nothing happens. So please never ever try this at home. Don't take off the cover or whatever. Just leave it to the experts.
This is nothing to wrench on, but then again, there is no need to wrench on this because it's already pretty much perfect as it is. So yeah, if you just leave it as it is, you're guaranteed to have a very long and joyful car life with it.
Right.
So Dennis, thank you very much for answering the community's questions.
You're welcome.
It was very nice. And for us, it's time to go on and meet the next expert. Follow me. Hello there.
Hey Felix.
Hey there, how's it going?
Great, and you?
I'm pretty good as well. So this is Kevin. Kevin, why don't you tell the viewers what it is that you do at Mercedes-AMG?
Yeah, I worked the last years on this beauty. We developed the P3 powertrain, and I worked for the CPC, that's the central powertrain controller. That's the brain of the car. So it decides when the engine provides torque, when the e-motor provides torque, and when we are driving electrically.
Perfect, because we received quite a few questions on the operating strategy of the whole hybrid system, so I guess you're the perfect expert to answer some of these questions.
I hope so.
Awesome. So we kick things off with the question by Patrick Vip, and he would like to know, by how much does the electric motor improve fuel efficiency and power output?
Let's say compared to a normal car like this, we can say that we improved by 10%, and that's in all-day driving, normal comfort driving. We see a big improvement due to the braking system and the energy we can get back there. Yes.
So is that comparable to, say, like a conventional, a P2 system?
Yeah, that's pretty comparable to what we see there. And so the P3 has no lower efficiency or something like this.
It's actually quite remarkable because, as we learned, the concept is quite different. It's very performance oriented, but we still have the same efficiency benefits.
Yeah, but we have the great benefit that the e-machine is directly on the rear axle and has not to go with the torque through the whole gearbox.
Ah, okay. The next question comes from Leonard Hassan. He would like to know, do the e-Performance models get a new gearbox?
So the basic gearbox you have in every car like this is nearly the same like in a comparable conventional car. We modified the software to be hybrid ready and a few hardware tweaks, but then we added a second gearbox in the rear of the car, and that's in the electric drive unit.
The next question also refers to that because Vier Augenmeli would like to know, does the transmission of the e-motor have more than one gear?
Yes, it has. We have 2 gears. That's the optimum for this car because we use the first gear to have a high torque in drive-off when you're driving electrical. And then we have the second gear to provide e-machine power up to the highest speed of the car. And that's pretty much the optimum for this car, yes.
So the sweet spot for this one is 2 gears?
Yes, it is.
Awesome. So then the next question comes from Nick D'Agostino, and he would like to know, is the hybrid technology mated to a V8 in any application?
Yes, it is, and you can see it here.
Nice,
when you want, you can hop in.
Of course.
Yes, let's drive off.
That sound though,
Yeah.
that is so cool. So the next question we got comes from B2 Engineer, and he would like to know, or she would like to know, how does regenerative braking work in hybrid powertrains?
Yeah, that's a good question, because that's part of the topics I did in this car. And it's quite easy, or the idea is quite easy. You try, or you do use the kinetic energy of the car to provide electric energy for the battery, so that you are boost ready after this. So when you step on the brake pedal, we are getting the energy back into the battery.
Pretty cool. So the next question we got comes from Evangelion in lead speak. Nice touch. How does the boost mode work? Will there be a button of any kind, or do you activate it with the gas pedal via kickdown?
Yeah, that's a good question. So the boost is always on, so you don't have to press a special button or something. You just press the acceleration pedal, and when you are in load increase of the combustion engine, it will automatically fill up and boost you. And when you keep staying on the acceleration pedal, then it will boost on top to the combustion engine power, and you will get the whole system power.
Nice.
So it's all automatic. You don't have to do something.
Pretty cool. Very nice. Very convenient too. Another question comes from Arne Aal, and he would like to know, will it be possible to drive EV only, and if so, what's the range? So we're driving EV only right now.
Yes, we are, but now we are in comfort mode, so it's automatic EV, but you can switch to electric drive only, and then you are driving an electric only.
Pretty cool.
Yes, and the range depends on the car in which we apply the powertrain. Yeah, and on the car weight.
So no specific numbers yet to communicate?
No, nothing yet.
Okay.
I can say that we can use 3.6 kilowatt hours of energy for electric driving.
Okay. So the next question we got comes from Tim Burton, quite the familiar name. I think we all know who that is. And he's thrown some punches, actually. Ring time will be interesting if they're saying it's only good for one hot lap of Hockenheim.
Yeah, I can assure you that we also tested the car at the Nürburgring, and we did some rounds there, and we can hot lap the Nürburgring. I can not name numbers, but we are able to.
Okay, so if this car has already been on the Nürburgring, I'm pretty confident that there's going to be some pretty interesting ring times as well.
Yes, it will.
Awesome. So here we are at the showroom. You can drop me off here. Thanks for giving me a ride.
Thank you too.
Awesome. And do not despair, because we're going to see this baby back in action later on. Joachim, hello there.
Hi, Felix.
How's it going?
Good, how are you?
I'm pretty good.
Nice to see you.
Nice to see you too. Why don't you tell the viewers at home what your job is at Mercedes-AMG?
Sure, so my name is Joachim. I'm here responsible for the electrical turbocharger, which you can see here in the inline 4-cylinder project. Yeah.
Perfect. So you're just the right expert to answer some community questions about the electric turbocharger. We received quite a few after the OMG video, so I'd say we begin with the first one. It comes from Masuchikari Engineer. I hope I pronounced that correctly. How do they work?
So you see here a section model of the turbo, so we can explain it like that a little bit. You have the classical turbo components. You have the turbine wheel inside the turbine housing. You have on the other side the compressor wheel and the compressor housing, which creates the boost pressure then for the engine. And what we added here for the electrical turbocharger is the E-machine here in the middle. So this little piece here, which sitting on the shaft, so like that, able to drive the whole shaft, turbine and compressor wheel. And on the bottom side you see the power electronics, which controls and spools up the E-machine itself.
Pretty cool. So many well-known parts, like these parts you recognize instantly, and these new parts, well, I mean, those are where the magic really happens. Pretty cool.
Yeah. Also
cool to see it in such detail here. That's really something else. And the next question related to the electric turbocharger comes from Brecht Van Este 908, and he or she asks how much power do they give, so in horsepower and in torque numbers.
So the turbocharger itself, so this E-machine in the middle here, delivers up to 6 kilowatt of electrical power, and that means in parallel that you can create up to 0.8 Newton meters, and that overall transferred to the engine gives us a power which is over 330 kilowatts.
That is just crazy. I mean, it's quite impressive to see what this little thing alone can do. Yep. Crazy, wow. So the next question comes from 5P4CK3N. I'm gonna spell it out, I'm not gonna pronounce it. How much more efficient are they compared to regular turbochargers?
That's a little bit tricky to answer because the efficiency is not related to the e-machine itself. The efficiency of the whole turbo is usually more driven by the aerodynamic efficiency of the turbine, the compressor, and also a little bit about the mechanical efficiency here of the bearing system. But what the e-machine gives us, it gives us more freedom in doing the layout of the aerodynamics. So like that, we don't have to make compromises when we optimize the turbocharger for some operating ranges, and like that, we don't have to make compromises somewhere else.
You already hinted to the next question because Strange 2020 asked, what is the actual purpose of electric turbochargers? Why do you even do something like that?
Yeah, so that's exactly as you said, that's a little bit the topic about compromises. You have to imagine we have an engine that delivers more than 330 kilowatts. That means out of 2 liters displacement actually. So that means you need a lot of boost pressure and a lot of air that's going through the engine means you have to also make a big turbocharger. But that's also a downside on the weight and on the speed and on the transient response of a turbocharger. And this gap we can close easily with the e-machine. So like that we can still boost up the turbocharger quite fast if you hit the pedal, or and also in low end torque areas we can deliver more torque on the engine at low engine speeds. And that's the main purpose. So you reduce the turbo lag actually.
Really cool. You already mentioned like combining the best of both worlds of both kinds of turbochargers, the small ones and the big ones. And you already mentioned speed, turbocharger speed. And the next question comes from Niklas695, and he asks, how much is the maximum rotation speed of such an electric turbocharger?
So this particular turbocharger speed has a maximum speed of 156,000 RPM. And wow. The e-machine itself can actually spool up the turbocharger up to 175,000 RPM.
That's just crazy. That's crazy fast. That must generate a ton of heat.
Yeah, it definitely does. Want to see it at the dyno?
Definitely, yeah.
All right, let's go.
Cool.
So you see the increase here is much faster now.
Wow, this is almost vertical.
Yes, it is already.
Wow, that is just crazy looking, like it's on a life support machine almost. And the way that turbo glowed up, that was just awesome. Awesome. Yeah. Really cool machine. So yeah, actually the next question comes from Cliffy Dude, and he would like to know, does an electric turbo spool up using electricity, or is electricity generated from the spooled up turbo as well?
In fact, it does both. So we use electricity to spool up the turbo, and in areas where we have enough exhaust gas energy, we can regenerate electric energy to feed the battery.
Much like with the braking, that's cool.
Yep.
It works both ways.
Yes, exactly.
Very nice, very cool. The next question comes from Naman Cienciato. I hope I pronounced that correctly. Is the turbocharger the only way this engine can take air in, or does it also take in air from the outside?
Hopefully it is, because if you would take it in air from the outside and bypass the compressor, then it would be leaking somewhere. So yes, it is kind of both. The turbocharger takes in air from through the air filter from the outside, pushes it into the engine, and like that generates the high power output. So yes, it does take in air from the outside, but just through the turbocharger.
Okay, okay. Then Noisy Boy would like to know, can they charge the battery from the e-turbo like in Formula 1 today?
Yes, exactly. We transferred the technology, as just said. It can, in some operating ranges, like in the Formula 1, regenerate electrical energy to the battery.
There you heard it again, Formula 1 technology for the road. Once again, really cool. So Joshua D. Stern would then like to know, what's the turbo lag like?
Turbo lag, we're going to see it right now on the graph. It is basically almost not there anymore. It is just a very linear increase in charge air pressure, and like that you don't feel a turbo lag anymore.
Cool, really cool. And lastly, we have Nidhi SG, and he or she would like to know, is the electric turbo actually more powerful than the normal one in horsepower?
Yeah, it is. So as previously explained, you have the classical turbocharger, which itself already has almost 45 kilowatts of thermal energy, which it gets from the exhaust gas. And we add to those 45 kilowatts, we add the 6 kilowatts of electrical energy. So yes, it is more powerful than the classical turbocharger.
Really cool technology, a lot to look forward to in future cars. Thank you very much, Joachim, for taking the time to answer these questions.
It was a pleasure.
And now it's time for me to head on outside for the next expert. Hello there, Jonas.
Hi, Felix. How are you?
I'm pretty good. How about you?
I'm fine, thanks.
Great to have you here. Why don't you tell the viewers back at home what it is that you do at Mercedes-AMG?
Sure. Yeah. As you said, I'm Jonas, and I'm an engineer for high voltage batteries at AMG.
High voltage batteries, so you know everything about energy capacity, energy going into the battery, out of the battery.
I hope so. Yeah.
So you're the perfect person to answer me some questions about the emotions that we have in our future cars.
Yeah. So let's have a test drive.
Awesome, let's hit the road. This sounds so awesome. This is the sound of the future.
Yeah, it is.
And it sounds damn good. So the first question that I got for you is from Heilmann494. And he asks, how will you ensure that AMG EQ generates the same emotions in analog to a 63 V8?
Yeah, good question. But yeah, I can probably answer with this. We still have a combustion engine in the front. In this car, it's actually a V8. So we're just improving this existing powertrain with an electrical powertrain. And so we improve the vehicle dynamics, meaning longitudinal and lateral dynamics. And so you just end up having an improved powertrain by having all the e-motors and batteries in the car.
So all electricity does is basically enhance the emotions.
Yeah, exactly. That's correct. And I just hope that every customer gets a chance to make an opinion on that.
I gotta say, also for myself, hearing the electric engine and this buzz that goes through the car, it already feels highly emotional. I mean, it feels like a spaceship.
Yeah, it does. Over there's a roundabout, and maybe after that we can just have a little kick down to see which emotions it causes.
That sounds like a good plan.
You ready?
I am.
3, 2, 1.
Okay, I'm sold. I'm sold on the whole idea of e-performance. Wow, that's like a rocket ship.
Yeah, it was my attention.
That's an instant punch. That's like instant punch. Even before the combustion engine kicks in, you already get that kick in the back.
That's absolutely correct.
Yeah, and the next question pretty much goes in the same direction. It's by P. Alban, and he asks, performance, performance, performance. But emotion, this thing cannot sound good. Sorry. And I gotta say, sorry, I disagree. I mean...
Yeah, I just hope that every customer gets the chance to make an opinion on this powertrain, because it's really unique, and you should get a chance to make your own experience on this product.
Absolutely. I mean, you heard it. It sounds amazing. The V8 sounds amazing. The electrical engine sounds amazing. And both together, that's just a symphony of emotions.
It is.
So the next question I got is from Silayas too, and he asks, how long will it maintain its maximum power capacity?
It's 10 seconds. So, yeah, if we just drive on a legal road at the moment, I cannot even show you these 10 seconds, because if I do, I would probably get some problems with my driver's license.
So that means 10 seconds, pedal to the metal, everything that goes. Yeah, I mean, I can't remember the last time I even got the chance to do that for 10 seconds straight.
Exactly, yeah. So you should probably get a chance on a racetrack to do that, but on a legal road, 10 seconds is more than enough.
Yeah. Well, I gotta say, it's always impressive experiencing these cars firsthand. I mean, nothing beats that. You can talk about it a lot, but just sitting here and feeling the power, especially the combined power of the combustion engine and the electric engine, that's just something else, and that really speaks for itself. So yeah, also emotion-wise, like I said, the future is very bright at AMG with the products that are about to come and about to hit the market. So yeah, experiencing these products is just something else. So thank you very much for letting me be a part of this experience.
Sure, you're welcome.
And thank you for asking all these interesting questions. That was very, very helpful for us because it shows us what topics we should do deep dives on. Big thanks to Joachim, to Dennis, to Kevin, to you, Jonas, for taking the time to answer these questions. That was very cool. And so yeah, if you've liked what you've seen today, don't forget to like the video. Also drop comments down below. Let us know what you would like us to shoot next. Subscribe to the Mercedes-AMG YouTube channel and also hit the little bell icon so you always get notified whenever we upload a new video. Jonas and I are going to go for another spin now. And until the next one, bye-bye.
Bye.